Hello, everybody. This is Tony Hain Shipkowski's Module 4 10-minute lesson to be recorded through Zoom. Right now, I'm with probably my three best friends. I have Jason Capello, Jordan Blair, and Ed Italian. They all also, unfortunately, work with me at Lebanon Middle School. So they're going to be my test subjects today for my teachable lessons. All right, you ready?
Yes, sir.
Yes.
All right, you guys should you can all see the video screen, but then you should also have the chat ability. If you can't, let me know. You can either use that or the video chat, just to answer the questions. All right, gentlemen, when you look at the word rational, what math word do you see within rational? Jason Capello. Ed raised his hand. Very good, Ed. Ed, what do you see?
Ratio.
All right, Jason and Jordan both also said ratio. Very nice job, gentlemen. It is ratio. Okay, does anybody have another clue? You can raise your hand, answer in the text chat, or verbally. What's another word for a ratio, or how can we write a ratio? Anybody have an idea? Ooh, Ed and Jason, nice job, fraction. Okay, so what I want you guys to remember for the rest of this lesson is a rational number is a number that can be written as a fraction. Okay, if you can write any number as a fraction, it's automatically rational. Irrational, on the other hand, is any number that cannot be written as a fraction. We'll talk about the two types. Actually, it's technically one that cannot be written as a fraction later. All right, so let's get into some examples here. On the screen, you'll see technically 8, but I want you to focus on the 4 in blue. And I want you guys to see if you can write any of them as a fraction, if they already aren't. So go ahead and take a minute and a half, 2 minutes. I'll put a timer on, and you guys see if you can come up with anything. If you think you know which 4 aren't, or excuse me, that can be written as a fraction, then just type in the letter of the the letter of which one you can write as a fraction. Bless you.
But I can see, I can see their answers. Does it matter?
That's okay. Jordan, you said A, B, D, and F. One of those is incorrect. We'll go over those here in a second. Ed's saying A, D, and C. You're missing one, Ed.
Can it be B as well?
What is it? B? It's actually A, B, and C. And D. Okay? Easy one. 1 3/4 already has a fraction. So it's automatically rational. We'll just put an R there for it. Okay? Letter A. You guys see how 15 ends in the 100ths place? So it'd be 15 divided by 100. Okay? Then for 0.121212 ... that ... means it goes on forever in that pattern. So you have 2 integers repeating, the 1 and the 2. And since you have 2 integers repeating, you place that over 2 nines, or 99. So it's 12 99s. That's how that works. That's something I never actually was taught until I learned it myself when I had to learn this stuff right here. C is a whole number. Every whole number can be written over 1. Okay? Now, we said A, B, C, and D are all rational. What about, Ed asked a good question. Does that reduce to 4/33? And the answer is yes, because 12 and 99 are reducible by 3 each. So that is equal to 4/33. Very nice job. Jordan complimented Ed as well. If you guys have any questions, please let me know. Does anybody see another one that you can reduce? Jordan's saying A. Very good, Jordan. What are they both reducible by? 5. Okay, so we divide both by 5. You get 3 divided by 20.
Warner.
Okay. Now for E and F, and then these two square roots down here, 3 of those are irrational. Pi is a constant in all circles. So the answer is 3.14159 ... goes on forever, doesn't have a pattern. Okay? Because there's no pattern, but it goes on forever, it is irrational. Okay? So I will type this list up after we're done here. And then this one right here, 2.38594. Jason, do you see a pattern at all?
No.
No. Since we have the ... that means it goes on forever with no pattern. This one's also irrational. Okay? Last two real quick before we move on, then I'm going to give you guys some time to try some on your own. When you have a square root, some people say, oh, they all are. They're really not. The only ones that are rational are perfect squares. So the square root of 16 is 4. 4 times 4 is 16. 5 times 5 is 25. So on like that. But the square root of 8 comes out to like 2.76 ... It goes on forever. There is no pattern. So these are irrational. You got to watch your square roots and all that. Okay, so we just did a really basic overview of what makes each of these rational or irrational. So I'm going to type that list up for you right here real quick. If you guys can remind me what each is. What's a rational? What's an example of a rational number? You can use any of the 4, 5, 6 examples we just did.
A number that can be written as a fraction.
Okay, so generally speaking, just a fraction. What else? Good job, Ed.
Whole numbers.
Whole numbers. Okay, one more. Or two more, excuse me, 2 more. Both of them deal with decimals.
Oh, perfect squares. Are you considering that one?
Actually, we can add that. Yep, perfect squares. Good job, Jason. And then the 2 decimals. What was the one type of decimal that we talked about that?
Oh,
Or percentages.
repeating.
Percentages. Yeah, they could be. But those are terminating decimals. And then Jason nailed the last one in the text, repeating decimals.
I'm ready
So
for
those
this test, Mr. Shipkowski. I'm ready.
What's that?
I'm ready for this test.
You ready for this test? All right, we'll see how you do on your homework later. Nice job, fellas. Okay, the last one, or the last 2 that we talked about that were not rational, okay, or irrational, are decimals. They kind of go hand in hand. They non-repeating, non-terminating. What does non-terminating mean? Anybody know?
They will never end.
They will never end. There you go. You're the language expert, Mr. Accounting. Non-terminating means it never ends. Okay? For those of you that aren't good with words, I'll type that in. Never ends. Okay? Immortal numbers. I like that. Good stuff. Okay. So there's your list. Ed's earning brownie points today. All right. There's your list. If they don't fit with your rational, they're irrational. If they fit with rational or don't fit in rational, then they're the other. Simple as that. So here are a couple examples. I'm going to write a couple more in there for you. But I want you guys to figure these out on your own. Okay, I'll give you a minute or two. Let me write one more in here since there's only 3 of us today. 6 minus 3 divided by 9 minus 4.
Or solve.
You're just going to tell me, are they going to be rational or irrational numbers based on the numbers that are involved already. So if I gave you, let me see, 3.12 repeating, so it looks like that, times pi.
Print the show work.
No,
Sorry,
you should be able to figure these out within 30 seconds. So 3.12 repeating times pi. 3.12 is a repeating decimal. It's rational. But pi is irrational. So if I would go and make this a regular problem and we would do the math, because one part is already irrational, that means the whole thing, the answer is going to be irrational. Okay? So Jason is saying B and D are irrational. Very good, because we'll figure out that later and why. Ed said A is rational, B irrational, C rational, and D irrational. Okay? And Jordan's copying off of Jason again. Okay? Thanks, Jordan. You guys are 100% correct. Now, why? Ed, can you explain to us why A is rational?
Because 3 times 8 is 24, and then you're going to multiply that by another whole number, so that's going to come out to be a whole number as well. So that's rational.
Perfect. Jason, why is D irrational?
You have a rational number multiplied with an irrational number like pi.
So 9 rational, pi irrational makes an irrational number. Very good. Jordan, 6 minus 3 divided by 9 minus 4. Are there any irrational numbers in there?
No.
No. So your answer is obviously going to be rational. Very good. All right. I'm going to give you guys 4 problems. I don't want you to answer anything until I'll give you about a minute or 2 to do this on your own. And I want you guys to tell me what each of the 4 numbers are, just like we just did. Okay? So the first one is going to be this. Square root of 100 divided by 9. This pen tool is not very user-friendly. The next one is going to be 6 pi divided by 2 pi. Be careful that one. That one's a challenge question. Let me think of another one. 4/3 pi times 6 squared. And somebody give me a number. Doesn't matter. Keep it school appropriate. 0. Okay, you got 4 problems. I'll give you a minute. I don't want you to type any answers in. I don't want you to answer them out loud. I just want you to answer them in your head, and then when we come back together, we'll share our thoughts. All right, go ahead. Jason's already done. Jordan, you done?
Sure.
If you're not done, don't tell me you're done.
Done.
Good?
Ed, you're good? Okay. All right. Jason, talk to me. Which one? Which one do you think is what?
Now, I could be wrong on the first one. That's the only one I find tricky. But the square root of 100 would be 10. 10 divided by 9 is a whole number. Unless it's
What do you
the
say?
square root of 100 divided by 9.
It's actually going to be, when you have the square root of a fraction, it's going to be the square root of 100 divided by the square root of 9. But what you said is still 100% correct because both of them come out to whole numbers.
All right. So
10 to,
6 pi over 2 pi, rational number.
it's rational.
Yes, it's 3.
Ah, very good. That was the tricky one. Think of it this way. You've got a pi on top, pi on bottom. You can divide by both.
You have a stack of pies.
You do. But because you're technically multiplying by 6 and pi on top here, and then dividing by pi on the bottom, they cancel out. So 6 divided by 2 is 3, which is rational. But before we go too much further, 10 divided by 3, Jason, you said it was 10 divided by 9. It's what you were explaining is still 100% correct because both numbers are still a whole number in a fraction. It's just 10 over 3 because the square root goes also to the 9 on bottom. All right, Jordan, 4/3 pi times 6 squared, rational or irrational?
Irrational.
Why?
Because of pi.
Because of pi. Everybody thinks pi is rational. Well, not the good kind anyway. But we'll talk about that later. 0. Anybody know?
Rational.
It's technically neither because 0 is technically not a number. But if we treat it as a number, it is rational because it's a whole number. All right? So your homework tonight is going to be pretty much 10 problems, just like the 4 or 5 we just did. You guys think you can handle it?
I got it.
Sounds good. I'll
Yeah.
send it to you guys in a minute.